Today we're going to look at coterminal and reference angles. Angles in standard position with the same terminal side are coterminal angles. You can find a coterminal angle by adding or subtracting 360 degrees if it's in degrees, or 2 pi radians. So if we look over here at this picture, we can see that our initial side's on the x-axis and our terminal side is at the y-axis, which means this is a 90-degree angle. So 90 degrees is the same thing as pi over 2. So the coterminal angle would be negative 270 degrees, or if we were using radians, negative 3 pi over 2. So those are called coterminal angles because they have the same starting position and same ending position. So it says give two coterminal angles for each angle, one positive and one negative. So for the positive, we take the given angle and we add 360 degrees since we're in degrees, which then gives us 433 degrees. So that would be my positive coterminal angle. For the negative angle, we would take 73 degrees and subtract 360 degrees, which gives us negative 287 degrees. And again, remember to always label these with a degree symbol if it's a degree measure. Otherwise, you would assume it's a radian measure. So negative 46 degrees, if we add 360 degrees to that, we get a positive coterminal angle of 314 degrees. And I added the 360 again because we want positive. So for the negative one, we would subtract the 360 degrees. So that would give us negative 406 degrees. Then the next two are radian measures, because again, we don't have that degree symbol. So for this one, if we have pi over 7, we want to get the coterminal angle with that. So we're going to add 2 pi. Well, if we're adding 2 pi to this, then that means we need to get a common denominator to add the fractions together. So we're going to multiply this by 7 over 7 to help us get a common denominator. And actually, let me move this up a little bit so I can write up here. So pi over 7 plus 2 pi. That would give us pi over 7 plus 14 pi over 7. And so once you have your common denominator, you just combine the numerator over your common denominator. So 15 pi over 7 is my positive coterminal angle. So you would do the same thing with the negative angle, except we're going to subtract 2 pi. So in this case, pi over 7 minus 2 pi is minus 14 pi over 7. So we already did that earlier up here, so I'm not going to write that again. But if you divide 14 pi over 7, you get 2 pi. So when I subtract, then I get negative 13 pi over 7. So that gives me my negative angle measure and my positive angle measure. So looking at question number 4, we have negative 2 pi over 3. So to find the positive angle measure, we're going to again add 2 pi radians to that. We need a common denominator, which means I would multiply this by 3 over 3 to get my common denominator. So this gives me negative 2 pi over 3 plus 6 pi over 3. And so then that would give me 4 pi over 3. So that is my positive measure, 4 pi over 3, that's coterminal. And then if we want a negative one, we could again then subtract instead of adding 2 pi. So negative 2 pi over 3 minus, and we already did 2 pi times 3 over 3 up here. So 6 pi over 3 is the same thing as subtracting 2 pi. Just means we have a common denominator. And so when we do that, we get negative 8 pi over 3. Now, these aren't the only answers. There's actually an infinite number of solutions that we can have because we can keep adding 360 or 2 pi or keep subtracting 360 or 2 pi. So these are just one possible answer. Of course, there's many. So down here it says to draw the given angle in standard form, then find two coterminal angles, one positive and one negative, and draw the coterminal angle in standard position. So for this one, if we have the given angle is 120 degrees, we know that's in quadrant 2 because this is 0 degrees, 90 degrees, 180 degrees. So we know 120 would be about up here. So we start at the positive x-axis because it's a positive angle measurement. We're going in the counterclockwise direction following the quadrants. The next one's asking us for a positive coterminal angle, so 120 degrees plus 360 degrees would give us 480 degrees. So if I have that, it still has the same starting and ending position, But for the picture, you start at the x-axis and you've already gone around once. That's 360 plus the 120 gives us this new drawing of 480 degrees, whereas this one was just 120 degrees. And as I said before, we can keep adding 360 to that. So if I take 480 and add another 360, 840 would be coterminal. And so how would I draw 840? I'm just going to erase here. That means I've gone around not just once, but twice. So this would be 840 degrees. And we could keep going. If I add another 360, I get 1200. I just go around the circle again. So lots of different possible answers. And as I said before, that's why there's an infinite number of possible answers. And then the same thing for if we do a negative angle. So 120 degrees minus 360 degrees gives me negative 240 degrees. So again, my starting and ending positions stay the same. The difference now is instead of going the counterclockwise direction, we're going to go in the clockwise direction because it's a negative angle measurement. So this is negative 240 degrees. And of course, we could keep going. So if we had negative 240 and subtracted another 360, that would be negative 600. And if we subtract another 360, negative 960 is also coterminal. So again, there's an infinite number of possible answers. The next one says sketch the angle theta 660 in standard position. So if you don't know where this is at, then I would suggest finding its coterminal angle to figure it out. So 660 minus 360 degrees means our coterminal angle is 300 degrees. So again, if this is 0 degrees, 90 degrees, 180, 270, all the way around is 360 degrees. 300 degrees would be, of course, somewhere in here. And so around my circle, this means that I've gone in the counterclockwise direction. So we went all the way around 360 plus another 300 gives me 660 degrees. So again, you need to draw that terminal side. And again, the arrow starting from the positive x-axis in the positive direction, so counterclockwise, to denote the angle that is drawn. Next, let's look at reference angles. For an angle in standard form, the reference angle is the positive acute angle. So what's an acute angle? An acute angle is less than 90 degrees. And formed by the terminal side and the x-axis. So steps to find a reference angle. Draw the angle in standard position. If the given angle is not between 0 and 360, then find the coterminal angle that is first. Create a triangle. Draw a vertical line from the terminal side, which hypotenuse to the x-axis. So here's the terminal side, and here's the x-axis. So we draw this right here, then you can see that terminal side's the hypotenuse. And the reference angle, again, is the positive acute angle formed by the terminal side and that shortest angular distance to the x-axis. So if you're on the left side of the y-axis, you're using the negative x-axis. If you're on the right side, then you would use the right side. Then you're going to find the acute angle formed. It may be part of the given angle, or it may be outside the given angle, such as in the picture over here. This is called a reference angle. So it says, draw each angle in standard form, sketch and find the reference angles for each angle. So we have 48 degrees. If we draw this, we know this is in quadrant 1, so 48 degrees is a little bit more than half. So here, this would be 48 degrees. So if I draw a right triangle, and again, the terminal side's the hypotenuse, well, you notice that that's already a positive acute angle. So that means that this angle right here is going to be equal to the given angle. So the reference angle, theta reference, is equal to the given angle. When you're in quadrant 1. So, but again, note that the given angle has to be between 0 and 360. So given angle between 0 degrees and 360 degrees. Because if it was not, then you would first find the angle between 0 and 360 and then find the reference angle. So 120 degrees we know is in quadrant 2 because 90 degrees is right here at the top and this is 180. So 120 would be towards the top. So from here to here is 120 degrees. So if we draw a line down to make a right triangle, the reference angle again is the positive acute angle formed by the terminal side and the x-axis. So that would be this angle right here. So notice that this one is not a part of the given angle. So in order to find it when we're in this quadrant, the reference angle is going to be equal to, so we have not gone past 180 degrees, so it's going to be 180 degrees minus the given angle. And again, that's if we're between 0 and 360. So this case, we would have 180 degrees minus 120 degrees. So the reference angle is 40 degrees. And again, so that would be this angle. Let me highlight it. So let's use green. So this angle is your reference angle. It's a positive acute angle. Same thing here. The reference angle is actually equal to the given angle there. So let's go to the next one, 215 degrees. So 215 degrees, now we are in quadrant 3. So 215 degrees is going to be about somewhere in here. This would be the angle drawn in standard position. Actually, I'm going to make this larger. So that's 215 degrees. So the reference angle, if I draw a line down to make a right triangle, the reference angle is going to be this angle right here. So again, if I highlight it, positive acute angle formed by the terminal side and the shortest angular distance to the x-axis. So now notice we've gone past 180 degrees. So if we want gone past 180 to find this angle measurement, we're going to take the given angle and subtract 180. So so this one was again for quadrant 2, you use that. So for quadrant 3, we take theta reference is equal to the given angle minus 180 degrees. As again, as long as your given angles between 0 and 360. So in this case, we have 215 degrees minus 180 degrees, which gives us 35 degrees. So that is our reference angle. Looking at the next one, now we're going to be in quadrant 4. So 304 degrees would be somewhere we're in here, right? So 304 degrees would be this direction. And so if I draw a right triangle, this is the reference angle. So in quadrant 4, the theta reference, notice that we are not using the 180 degrees to add or subtract from. Now we have not quite made it all the way around to 360 degrees. So now we're using the positive x-axis, which is all the way around 360 degrees. So to find the reference angle, you're going to take 360 degrees minus the given angle. And again, the given angle has to be between 0 and 360. So in this case, 360 degrees minus 304 degrees, which gives us 56 degrees. So that is our reference angle. So that's when we're using degree measures. And of course, we can also do this when we're using radians. And so before we get to the radians, let's do a couple other ones where theta is not between 0 and 360. So looking at the first one, 585, that is not between 0 and 360. So first we're going to find the positive coterminal angle. So the positive coterminal angle, take 585 and subtract 360 degrees, and we get 225 degrees. So 225 is coterminal. Well, we know 225 is in quadrant 3. So we're going to go ahead and draw, 220, I said 225, sorry, I don't know why I wrote that, 250, no, that's right, 225, okay, yes, okay, so we have 225, and then, so that's going to be right here, and so if I draw 585, though, 585 would go all the way around 360 plus the 225, so this is 585 degrees drawn in standard position. But we want the coterminal, or sorry, the reference angle. So the coterminal angle we just found was, again, let's write that down, 225 degrees. So the reference angle is going to be this angle right here. So to find the angle, again, since we're in quadrant 3, we're going to take the given angle that was in between 0 and 360. So we had to find the coterminal angle to do that, and then subtract that from 180 degrees. So the reference angle is going to be 225 degrees minus 180 degrees, which gives us 45 degrees. That means this angle right here is 45 degrees. So let's do negative 400. So negative 400. So if we add 360 degrees to that, we get negative 40 degrees. Well, that's still not between 0 and 360. So again, as we said up here, if theta is not between 0 and 360, first we want to find that. So that means we need to add another 360 degrees to this. Oops. Which gives us 320 degrees. Well, 320 degrees, you know, is in quadrant 4. So 320 would be about somewhere here. So, however, if we're drawing the picture for this in standard position, negative 400 has gone all the way around. So that would be negative 360, and then all the way around again, plus this extra here. So that's the angle drawn in standard position for negative 400 degrees. Then we want the reference angle, which is this angle right here. And again, in order to find that, we need to use the coterminal angle between 0 and 360. So we said that was 320 degrees. So to find the reference angle, we haven't gone past 360. So 360 degrees minus 320 degrees, which is equal to 40 degrees. And I just realized that I totally went around too many times for that. Let's try this again, sorry. So this would be negative 360, and then the 40. There we go. That's much better, right? For some reason I was doing the other way, so sorry. So if you look, negative 360, if we subtract the 40 from that, that gives us negative 400. I don't know what I was doing before. Sorry about that. So this would be the angle for negative 400 drawn in standard position, and then the reference angle is just that distance from here to here, which is negative 40 degrees, but we don't use the negative, again, because it's a reference angle, so we just say that the reference angle is 40 degrees. All right, what happens if we are in radians? So if we're in radians, again, you can turn this into a degree measure if it helps you figure out where the degrees is. So if I multiply this by then 180 over pi, that is going to change this into a degree measure. So remember, if you need to use your calculator, you can. So if we have, in this case, so we have, in this case, 7 times 180 and divide that by 5, we get 252 degrees. So that's equal. So that's just the degree measure for the radian measure. So in this case, 252 would be in quadrant 3. Somewhere in there. So that is 7 pi over 5, or 252 degrees. So if we're doing this with radian measures, then instead of using 180 degrees, which is right here, we're going to use pi to find the reference angle. So we use the same ideas, it's just with pi. So the coterminal angle to 7 pi over 5 doesn't have a coterminal angle. It's just 7 pi over 5. So if I wanted to find a coterminal angle, I could add 360 to that. So it's already between 0 and 360. So if I wanted to find a coterminal angle, if I add or subtract 2 pi, then I would get a common denominator, multiply this by 5 over 5. So that would give me 10 pi over 5 plus 7 pi over 5. So coterminal angle would be maybe 17 pi over 5. But we want this angle between 0 and 360, or so this one's between 0 and 2 pi already. Okay. So this one's the coterminal though. So the reference angle then, the reference angle is going to be, since we've gone past, we would take 7 pi over 5 minus pi. So again, it's very similar to the one we did up here, except for we're not using 180. You take the given angle and subtract 180, or in this case, because we're in radians, pi. So that means we need a common denominator, multiply this by 5 over 5. So when we do that, 7 pi over 5 minus 5 pi over 5 gives us 2 pi over 5. Now, could you also do this with the degree measure? Sure. So if you wanted to take 252 degrees minus 180 degrees, that would give us 72 degrees, but then you have to put it back in radians because it's in radians. So 72 times pi over 180. So 72 divided by 180, hit the math fraction key, and then put the pi back in. So 2 pi over 5. So that would be fine to do that as well. So looking at the next one, we have 11 pi over 18. So again, you could multiply this by 180 over pi to figure out what it is coterminal with, which ends up being 18 over 180, and then so that's 110 degrees. So that's in quadrant 2, about up here. So that is 11 pi over 18. You always want to use whatever you're given. So if it's in radians, use radians for your answers. If it's in degrees, use degrees for your answers. So the reference angle in this case, again, just like the one we did up here, when we were in quadrant 2, you're going to take 180 minus the given angle, but since we're in radians, we're going to take pi minus the angle. So pi minus the given angle, which is 11 pi over 18. Pi minus 11 pi over 18. We need a common denominator, so if I multiply this by 18 over 18, that gives us 7 pi over 18. So that is the reference angle. And again, could you do this with degrees and then convert it? Sure. So 180 degrees minus 110 degrees gives us 70 degrees if we're using degrees. And then you would take 70 degrees and multiply that by pi over 180, which ends up giving you 7 pi over 18. Now, coterminal angle, so let's do a negative coterminal angle this time. So we have 11 pi over 18. If we want a negative coterminal angle, we would subtract 2 pi. So then we would multiply this by 18 over 18. Which gives us 11 pi over 18 minus 36 pi over 18, which then would give us negative 25 pi over 18. So that's a coterminal angle, or it could have added instead of subtracting. But in this case, we already had the given angle between 0 and 360, so I just found a different one. So this one I found a negative and positive one. So next is just more practice of what we did the other day around the circle. So I would go ahead and pause the video and see if you can use what we learned yesterday to write the radian measures around the circle for your special angles 30, 45, 60, and then 90, and all the way around. All right, so remember yesterday we talked about you can count by 30 degrees around, which is pi over 6, because 30 times pi over 180 is equal to 3 pi over 18, or pi over 6. So this is 1 pi over 6. Then we had 2 pi over 6, which remember we said is really equal to pi over 3. And then we had 3 pi over 6, which reduces into pi over 2. This one was 4 pi over 6, which reduces into pi over 3. Then we have 5 pi over 6. 6 pi over 6 is pi. 7 pi over 6. And then down here, 8 pi over 6, which is really 4 pi over 3. And then 9 pi over 6, which is 3 pi over 2. This would be 10 pi over 6, which is 5 pi over 3. And 11 pi over 6. And then all the way around would be 12 pi over 6 or 2 pi. And so again, we don't really write the ones that aren't reduced around our circle, but just counting with those around your circle helps you get your radian measures around the circle. So you can do the same thing with 45 degrees times pi over 180 gives us pi over 4. So this would be 1 pi over 4, 2 pi over 4 is pi over 2, 3 pi over 4, 4 pi over 4 is pi, 5 pi over 4, 6 pi over 4 is 3 pi over 2, and 7 pi over 4, and 8 pi over 4 would be all the way around your circle, which is 2 pi. So that completes the lesson for today. So that is, again, for reference angles and coterminal angles. Now you can complete your homework.